Welcome to the CompTIA Project Plus Prepcast by baremetalcyber.com. In most projects, the information technology infrastructure serves as the foundation on which all technical operations run. This infrastructure includes computing resources, networking capabilities, and data storage systems, each of which must function reliably to support the project's objectives. The project manager needs at least a working understanding of how these components fit together so that potential risks, dependencies, or capacity limitations can be addressed early. Without this knowledge, decisions on scope, schedule, and budget can be compromised by unplanned technical issues. IT architecture refers to the deliberate structuring of systems, applications, and components so they operate as a cohesive whole. It includes not only the hardware and software, but also the networks, data flows, and user interfaces that connect them. Well-designed architecture supports scalability so that systems can grow with demand, provides strong security to protect assets, and optimizes performance so that users can work efficiently. Poor architecture, by contrast, can result in bottlenecks, vulnerabilities, and expensive redesigns. One common architectural pattern is the multitiered approach, where functions are separated into distinct layers, such as presentation, business logic, and data. In this model, the user-facing layer handles the interface, the middle layer processes rules and logic, and the data layer stores and retrieves information. This separation improves maintainability, allows for load balancing across servers, and can enhance security by isolating sensitive data. It is widely used in enterprise applications, client-server setups, and modern web services. When selecting an architecture for a project, the project manager must evaluate how well each option aligns with scalability goals, expected uptime requirements, and the ability to integrate with existing systems. The choice of architecture will influence timelines, required expertise, and budget allocations. For complex or long-term projects, consultation with a solution architect can help ensure that the chosen design meets both current and future needs while fitting within operational constraints. Networking is another core element of project infrastructure, enabling communication between users, systems, and services. Networks may include local area networks for office connectivity, wide area networks linking multiple sites, virtual private networks for secure remote access, and cloud-based network services. Without reliable and well-managed networking, essential functions like data transfer, remote collaboration, and real-time communication can be disrupted, impacting project delivery. The physical and logical components of a network each play a vital role. Switches connect multiple devices within a network, routers direct traffic between networks, firewalls filter and protect against unauthorized access, and wireless access points provide mobility within defined areas. A project manager must confirm that the network design supports the tools, applications, and geographic distribution of the project team, and that it can handle the expected load without degradation. IP addressing and subnetting are fundamental to network organization. An IP address uniquely identifies a device on a network, while subnetting divides a larger network into smaller segments to improve performance and security. Incorrect configuration of addresses or subnets can lead to communication failures, security vulnerabilities, or inefficient routing. Even without deep technical expertise, a project manager should ensure qualified personnel are managing these settings and documenting them clearly. Bandwidth is the measure of how much data can be transmitted over a network connection in a given amount of time, and it directly affects network performance. Projects that rely heavily on video conferencing, large file transfers, or cloud-hosted applications require sufficient bandwidth to maintain productivity. The project manager should work with IT to assess expected usage patterns and ensure that network capacity meets peak demand without introducing delays or disruptions. When deciding between wireless and wired networking, the trade-offs must be carefully weighed. Wireless networks offer mobility and easier installation but may suffer from interference, signal range limits, or reduced speeds compared to wired connections. Wired networks provide higher throughput and stability but limit flexibility in workspace arrangement. The project manager must balance these considerations to support the project environment effectively, whether in an office, data center, or field location. Network security is a critical concern in any infrastructure discussion. Protective measures may include firewalls to control traffic, intrusion detection systems to identify threats, and secure Wi-Fi protocols to prevent unauthorized access. Network segmentation, dividing the network into distinct sections, can help isolate sensitive systems from general user access. The project manager should confirm that all networking plans align with organizational IT security policies and regulatory requirements to avoid introducing vulnerabilities. Data storage technology is the final major pillar of infrastructure planning. Options include local drives within individual systems, network-attached storage for shared file access, storage area networks for high-performance needs, and cloud-based storage services for scalability and remote access. The choice depends on factors such as cost, speed, capacity, redundancy, and regulatory obligations. The project manager must ensure that the storage solution supports both performance needs and data protection requirements. Backup and recovery planning is essential to protect against data loss from hardware failure, cyber attacks, or human error. Strategies may involve full backups, incremental backups, or continuous cloud synchronization, depending on recovery time objectives. These objectives define how quickly systems must be restored to minimize impact on project timelines. The project manager should confirm that backup procedures are tested and documented so they can be executed without delay if needed. Performance and availability of storage systems are influenced by several factors, including read and write speeds, the use of RAID configurations for redundancy, and replication across multiple locations. Storage must be able to handle peak workloads without causing slowdowns, especially in collaborative projects where multiple users access the same resources simultaneously. The project manager should verify that the chosen solution meets these performance benchmarks and availability targets. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. In infrastructure-heavy projects, documentation is not just a formality, it is a functional asset. Diagrams, inventories, and configuration records help track all components and their relationships within the environment. Accurate documentation supports smooth handoffs between teams, speeds up troubleshooting, and provides a verifiable record for audits. The project manager must ensure that this documentation is kept current throughout the project lifecycle, especially when hardware or configurations change. Virtualization is a widely used method to optimize infrastructure resources by allowing multiple virtual machines to run on a single physical host. This approach improves utilization rates, reduces hardware costs, and offers flexibility in scaling environments up or down. It also plays a key role in disaster recovery strategies by enabling quick replication and redeployment. The project manager may need to coordinate with IT to provision these virtual resources and align them with project workloads. For projects involving analytics or large-scale reporting, data warehouses provide a centralized repository for structured data from multiple sources. These systems enable the generation of reports, dashboards, and historical trend analysis that inform decision-making. The project manager often works with business intelligence teams to design and schedule data flows into the warehouse, ensuring that data integrity, security, and performance requirements are met. Scalability is a crucial consideration in infrastructure planning, as most projects must support future growth without requiring a complete redesign. Scalable systems can accommodate more storage, additional processing power, or increased user load with minimal disruption. The project manager should evaluate whether the solutions being implemented are adaptable enough to handle projected growth over the expected lifespan of the project. High availability and redundancy measures are implemented to keep systems operational in the event of component failures. This might include redundant internet connections, RAID-configured storage arrays, backup power systems, and failover servers. The project manager must identify uptime requirements with stakeholders and ensure that the infrastructure design meets those targets, particularly for mission-critical systems, where downtime carries significant cost. Network diagramming is a practical tool for planning and managing infrastructure. These diagrams visually represent connections, devices, and data flows, making it easier for stakeholders to understand the layout and for teams to troubleshoot issues. Project managers should request or maintain updated diagrams for any environment the project depends on, both for planning purposes and for use during operational reviews or audits. Cloud infrastructure is now an integral part of many projects, often used in hybrid models that combine on-premises resources with cloud-hosted services. The project manager must understand how the cloud environment integrates with existing networks and storage systems, as this can affect performance, security, and cost. Cloud-based infrastructure often introduces new roles, monitoring tools, and billing models that must be incorporated into the project plan. For on-premises projects, data centers remain a core facility for hosting servers, storage, and networking equipment. Project managers must consider space, power availability, cooling systems, and physical security when planning for data center use. These constraints can directly influence deployment timelines and budgets, especially if upgrades to the facility are required to accommodate new hardware. Monitoring and performance management tools allow teams to track system health, uptime, and resource usage in real time. Alerts generated by these tools enable proactive maintenance before issues escalate into outages. The project manager can use performance reports from these systems to assess readiness and ensure that infrastructure meets both technical and operational requirements throughout the project. Security integration must occur across every layer of the infrastructure, from hardware and networks to applications and user access. Controls might include firewalls, encryption, network segmentation, and identity management systems. The project manager has a responsibility to verify that these security measures are implemented consistently and that they match the sensitivity level of the project's data and operations. Licensing and cost planning for infrastructure involve understanding the different models used for hardware, software, and cloud services. Costs may be fixed through perpetual licenses, recurring through subscriptions, or variable based on usage. The project manager should track these expenses closely to prevent budget overruns and ensure that license terms align with the project's operational and scalability goals. Ultimately, the role of the project manager in infrastructure projects is to coordinate between IT teams, vendors, and stakeholders to ensure that all components align with business needs. This includes managing timelines, mitigating risks, allocating resources, and translating technical requirements into actionable project deliverables. A strong grasp of architecture, networking, and storage fundamentals enables the project manager to anticipate potential issues and guide the project toward successful execution. IT infrastructure forms the backbone of modern projects, and effective planning is key to ensuring performance, security, and scalability. By understanding the technical foundations and aligning them with project goals, the project manager can help deliver solutions that meet immediate needs while remaining adaptable for future growth. Thank you for listening. Please follow baremetalcyber.com on social media and check out our books at cyberauthor.me.